Welcome to Share My Lesson. In this video, we will be looking at the 2024 Australian Mathematics Competition Sydney Solutions. Please check the description below for more information. Now let's move on to the solutions. We can use the distribution law to solve this question. As you can see, we get 100 times 346, which gives 34,600. So the answer is D. The formula for the area of a triangle is half base times height. The base is 9 centimeters and the height is h. So we get an equation where 9 times h divided by 2 is equal to 36. We can solve this to find that h is equal to 8 meters. This means that the answer is D. To solve this question, we need to simplify the numerator and denominator into single fractions. The numerator gives a fraction of 11 on 6, and the denominator gives a fraction of 1 on 6. The 6's cancel out, which gives 11. This means the answer is E. The sum of the interior angles of a quadrilateral is always 360 degrees. Using this information, we can solve for the unknown variable. We find that theta is equal to 10 degrees, which means the answer is B. Let 0.6n be equal to 17. We can solve this to find that n is equal to 28 and 1/3. The closest integer to this is 28. This means for any n up to 28, the value of 0.6n is smaller than 17, which means that the largest such integer is n equal to 28, which gives E. We can prime factorize 2024. This gives 2 to the power 3 times 11 times 23. So the missing value is 3. This means the answer is D. There are 1,000 meters in a kilometer. So 6 kilometers is 6 times 1,000 meters. And there's 60 minutes in an hour. So 1 hour is 60 minutes. So we get the fraction 6 times 1,000 on 60. This simplifies to 100 meters per minute, which means the answer is B. Since the figure is divided into 6 equal squares, and each has an area of 16 centimeters squared, and a side length of 4 centimeters, the perimeter of the rectangle is 10 of these sides, which gives 40 centimeters, and so the answer is E. L needs to give M at least 6 $50 notes to pay at least $270. However, the $30 change required from 6 $50 notes cannot be made with $20 notes. So L needs to give M at least 7 $50 notes. The $80 of change from 7 $50 notes can be made with 4 $20 notes. So the minimum number of notes that will need to be exchanged is 7 plus 4, which is 11. This means the answer is E. There are 3 semicircles of diameter 1, 2, and 3. The lengths of these semicircular arcs are pi and 2, pi, and 3 pi, making the perimeter pi and 2 plus pi plus 3 pi, which evaluates to 3 pi. This means the answer is C. Each of the 5 squares have an area of 100 centimeters squared. The triangular shaded area is 1/4 of a square, and the smaller square shaded area is also 1/4 of a square. As you can see, there are 4 of these 1/4 areas, and there are 5 squares, which means 5 minus 4 times 1/4, which gives 4. As we know that each square is 100 square centimeters, we just times this by 4. This gives a total area of 400 centimeters squared, so the answer is B. Suppose that the number of minutes is m, and the number of seconds is s. Then the conditions of the problem imply that 1.6 times 60m plus s is equal to 100m plus s. And also, the 96m plus 1.6s is equal to 100m plus s. We also get that 3s is equal to 20m. So b is divisible by 20 and must either be 0, 20 or 40. Solving for a then gives the times 000, 320 and 640. Since Michael intended to heat the pie for longer than 4 minutes, he must have intended to heat it for 6 minutes and 40 seconds, which gives 400 seconds in total. So the answer is C. If Simon had an X cars, then before her birthday, Merle must have had 2 on 3 X cars, and afterwards she had 3 on 2 X cars. The difference between these two values is 20. So we get the equation 3x on 2 minus 2x on 3 is equal to 20. We can solve this to find that x is equal to 24, which means the answer is D. We know that a plus b squared is equal to a squared plus 2ab plus b squared. We can apply this to this question. We find that this evaluates to 4 to the power 7 plus 9 to the power 8 plus 6 to the power 8, which gives an answer of A. Since a cubed divides b cubed if and only if a divides b, the answer is the same as the equivalent question for a pair of standard dice numbered 1 to 6. The following table shows when the blue dice roll divides the red dice roll. Since all 36 outcomes are equally likely, the probability is 14 on 36, which simplifies to 7 on 18. So the answer is C. Suppose that the two distinct integer solutions are a and b, where a is greater than b. This means that the quadratic equation factorizes as x minus a times x minus b. This means that a times b is equal to 2024. which has a prime factorization of 2 cubed times 11 times 23. This means that k is equal to negative a plus b. We can then make a table to find the values of a, b, and k. Altogether, there are a total of 8 possible values of k, which means the answer is C. As per the diagram, label the square as shown. Triangle ABX is congruent to triangle BCZ. The only difference is that it's rotated 90 degrees. As you can see, segment CZ is perpendicular to the segment BX. This means CW is a median of the isosceles triangle BCY. This means triangle CBZ has a line segment CZ of root 5 units. Similar to triangle CBZ is triangle CWB, with the segment of CB is equal to 2 units. This means CW is equal to CB. So CB on CZ gives a ratio of 4 on root 5, and BW is equal to ZB. And CB on CZ is equal to 2 on root 5. This means that BY is equal to 2BW, which is equal to 4 on root 5. So the area of the triangle BYC is equal to a half times 4 root 5 times 4 root 5, which simplifies to 8 on 5. So the answer is B. There are 10 data points on the original scatter plot. So the vertical median line passes through the average of the 5th and 6th people values. Likewise, the horizontal median line passes through the average of the 5th and 6th devices' values. It just happens that in both measurements, the 5th and 6th values are equal. This is why each median line passes through at least 2 points, rather than halfway between 2 points. When a new data point is added, there will be 11 points in all, so the new median lines must pass through the 6 people and device values respectively. The 6th value in the new dataset will be equal to either the 5th or 6th value in the original dataset, depending on the location of the new data points. But since these values are equal, the location of the new data points is actually irrelevant and neither median line will need to move. So the answer is B. On a non-leap year, February has 28 days, so it has 4 of every day of the week. Only in a leap year, when February has 29 days, can there be 5 Thursdays, and only when the 1st of Feb is a Thursday. From 1st of Feb 2024 to 1st of Feb 2028 is a total of 1,461 days, which is 208 weeks and 5 days. So the 1st of February 2028 is Tuesday. Similarly, any period of 4 years this century is 1,461 days, so the day of the week advances 5 days. From a leap year to have a 1st of Feb on a Thursday requires 7 such advances of 5 days, so a total of 28 years. So 28 years later is the year 2052, which means the answer is D. As you can see, we can label the diagram as shown. Next, we can find an equation for x and y. We find that x and y is equal to 0.06 and x plus 3 on y is equal to 0.08. We can label these respectively as equations 1 and 2. We can subtract equation 1 from equation 2 to find that x plus 3 on y minus x minus y is equal to 0.08 minus 0.06. We solve this to find that y is equal to 150. Now going back to equation 1, we substitute this y value of 150 to find x. We find that x is equal to 9. So the total tree height is x plus 1.5, where x is equal to 9, which gives a total of 10.5 meters. This means the answer is D. The books must alternate between fiction and non-fiction. There's a total of 4 factorial, which is 24 ways to order the 4 fiction books, and there are a total of 3 factorial, or 6 ways to order the 3 non-fiction books. In total, the number of arrangements is 24 times 6, which gives a total of 144. So in total, there are 144 arrangements, and the answer is A. To solve this question, let's first factorize 2024. A times b squared minus c squared is equivalent to A times b minus c times b plus c. The pair factors b minus c and b plus c have a difference of 2c. This means that they are both either odd or both are even. So we can use a table to test all the possibilities. First, let's find the factors of 2024. Then we can use this to factorize 2024 is equal to b minus c, b plus c times a. We first find the possibilities where b minus c is odd. Next, we find the possibilities where b minus c is even. We can complete the table as follows. As you can see, there's a total of 17 cases, which means the answer is E. Draw a perpendicular line, HX, to the line CD, and draw the diagonals of rectangle EFGH. This means FH is equal to EG is equal to AB, and HX is equal to AD. So the ratio between HX and HF is 1 to 2. That is, the triangle FXH is a right angled triangle with a hypotenuse twice the length of one side. We can mark the angle XFH as theta. This means that sin theta is HX and HF, which is equal to 1 and 2. So theta is 30 degrees. As you can see, the triangles EFG and FEH are similar. This means that the angle EFH is equal to the angle FEG, which is equal to alpha. So 2 alpha is equal to 30 degrees, which means that alpha is equal to 15 degrees, which means the answer is A. Let A, B, C, D, E, and F be the number of problems completed by each student respectively. This means that A, B, C, D, E, and F are in between 52 and 59. However, none of these numbers can be prime, since the total number completed by each student is k plus 1 times the number completed on Saturday. Eliminating the primes 53 and 59 gives you A is equal to 52, B is equal to 54, C is 55, D is 56, E is 57, and F is 58. For each student, the value of k plus 1 will divide the numbers of problems. Here's a table showing possible values of k for each student. Since each student has a unique value of k, we need to identify 1k for each student. Only Daria can have k is equal to 6. So Daria can't have k equals to 3. So Amy must have k equals to 3. This means A, which is Amy, is the only possible solution. By symmetry, the center of the sphere is in the vertical plane that includes the lowest edge. Consider a cross-section in that plane. Since A is the midpoint of an edge of the tetrahedron, line AC is the altitude of an equilateral triangle of side 2, so that AC is equal to root 3. Using Pythagoras, we find that BC is equal to root 2. Also, if R is the radius of the sphere, then BX is equal to BY, which is equal to R, which means that AX is equal to AZ, which is equal to 1 minus R. We can conclude that CY is equal to CZ, which is equal to root 2 minus R. Then AC is equal to AZ plus ZC, so that root 3 is equal to 1 minus R plus root 3 minus R, which gives a diameter, which is 2R, 1 plus root 2 minus root 3. This means the answer is D. We only need to consider the ratios of areas on the front face of the vase. The question considers the height of the vase divided into thirds and halves, so divided into 6 layers as shown in the diagram. The arithmetic progression in the areas of these 6 layers is indicated using the smaller areas A and B. We can label the diagram as shown. This means that 2A plus 9B on 6A plus 15B is equal to 1 and 2. We can simplify this to find that 3B is equal to 2A. M and N is equal to 3A plus 12B divided by 6A plus 15B. Substituting equation 1 into equation 2, we find that M1N is equal to 3A plus 4 times 2A on 6A plus 5A times 2A. The A values gets cancelled out, which gives the fraction of 11 on 16. 11 plus 16 is equal to 27. Since this fraction is already in the simplest form, n plus n is equal to 11 plus 16, which is equal to 27. So the answer is 27. Label the points P0, P1, P2, all the way to P21 in order around the circle. We can write down an equation for S, which is what we want to calculate. By symmetry, we see that P0 and Pi is equal to P0 and P22 minus R. With this, we can write another equation for S. As you can see, P0 and P11 is the diameter of a circle. This means that P0 and P11 squared is equal to 36. Further, the angle P0, PI, and P11 is 90 degrees. This means that this is a Pythagoras triangle. For the values of I is equal to 1, 2, all the way to 10, this means that P0, P11 minus I is equal to PI, P11. Therefore, we can write an equation for S. Earlier, we found that P0, P11 squared is equal to 36. Similarly, P0, P1 squared is 36, P0, P2 squared is 36, all the way to P0, P11. Therefore, S is equal to 11 times 36, which is equal to 396. This means the answer is 396. Let AN is equal to PN on QN, where PN and QN are integers. Next, using this, we can write another equation. For example, let's start with P1 is equal to X and Q1 is equal to 1. We can draw a table as follows. We claim that AN is equal to n plus 1 times X minus n minus 1 divided by n minus 1x minus n minus 3. Using this, we can find the value for A33, which is equal to 2024 divided by 1905. Then we can write another equation with the variable x. If we solve this equation by cross-multiplying, we get that negative 2x is equal to negative 240, which means that x is equal to 120. So the answer is 120. Given that there are 12 socks, there's a total of 12C5, which evaluates to 792 ways of choosing 5 socks, with each of these possibilities being equally likely. There are only 2 ways he can get exactly 1 pair: 2 socks of one color and 3 single socks, or 3 socks of one color and 2 single socks. We can draw a table that summarizes these as follows. In total, there is 416 on 792 ways. We can simplify this to the fraction 52 on 99. This means that m is equal to 52 and n is equal to 99. We need to find m plus n, so we simply add these together to get a sum of 151. This means the answer is 151. As you can see, we can write an equation for x as follows. To solve this question, we need to solve this equation. First, we multiply both sides by the cube root of 3 minus the cube root of 2. This equation that we get is equal to 1. So the cube root of 3 minus the cube root of 2x is equal to 1. Taking the cubes of both sides, we find that this equation is equal to 1. Since the cube root of 3 minus the cube root of 2 is equal to 1 on x, we come to the conclusion that 1 minus 3 on x times the cube root of 6 times x cubed is equal to 1. We can expand and simplify this to find that x cubed minus 1 is equal to 3 times the cube root of 6 times x squared. Now let's take the cube. As you can see, we can expand this to find the coefficient of x to the power 6. We find that this coefficient is negative 165. We want to get the positive value, however, which is 165, which means the answer is 165. We have now completed the solutions to the AMC 2024 Senior Division. Please make sure to subscribe to my channel and check out my blog for more information.